Good morning, everybody. Welcome to today's Net Lab, where we're going to be talking about securing that network. If you were here a couple weeks ago, we kind of went through the basics of wireless security, different aspects that we can actually use from that. And today we're going to get into a little bit more of the nuts and bolts of that, especially with the Steam Horizon series, and walk through exactly how do we implement, best practices for that security. So with that, we're going to kind of get rolling. As we start talking about this, really what we want to look at is for Esteem, really where we are involved with this is within the industrial automation. So we're very heavy into water and wastewater, oil and gas, mining, material handling, power and energy, agriculture, infrastructure, factory floor automation. So within this, security is, as you can imagine, is paramount, and especially as this becomes now of a critical component within these networks that we've talked about. Securing that, or making sure that that data is private and secure, is really a very important aspect. As we kind of look through this, we also want to kind of take in mind that says, we've really had a big change within this digital transformation, is what a lot of people are calling. And really what we're doing is we're taking this from a serial-based communication scheme, which has historically been kind of what's been involved with industrial automation. These were PLCs talking to PLCs, or device level talking to other devices. And there's been a transformational shift now, in that we're now going into this Industry 4.0. This is also really kind of where we've moved from that serial-based communications into Ethernet-based communications. And not only are we changing kind of the way that that data is handled and the data itself, but now all of a sudden we're moving from that device level communications into network communications. So as you can imagine, security is even more important as we start bringing this into a complete network. So we kind of look at what that connected model looks like today. Is really we've got things out in the field. These are your devices, these are your PLCs, these are your end pieces that are out for, say, the remote assets. Then we've got to have connectivity, and basically, so that we can get that data. Now, whether we're going to store that, we're going to stream that. But ultimately, what we're trying to do is to get it to that area over on the far right side where we can analyze it and act upon that data. Okay, so as we kind of take that same model or that same idea and now apply this a little bit further out, we start looking at industrial automation, these kind of networks that we're heavily involved with. Well, we're faced with kind of some unique challenges. And so what you see within industrial automation is typically we're now trying to bring in remote assets that can be very long distances. These can be city or county-wide coverages. We're trying to get across roadways. We're trying to get across waterways. A lot of the applications where we actually have mobile vehicles, whether that be an AGV or a maintenance vehicle, things are not stationary. And so when we start talking about these remote assets in these unique challenges, a lot of times this is where wireless is implemented and brought into the equation. Now, in addition to just kind of our devices, what we're seeing now is we're implemented not only within the home, but also this industrial automation is the IoT, right? So we want to have connectivity to everything. What we're trying to do, whether that's cameras or analytics or machine learning, is everything now is being connected into that network. That all is being done wirelessly, or a good portion of that. With that becomes really the biggest security, or probably the biggest question mark or hurdle to overcome, is this idea of the security of that data. We want to make sure that as we're putting more of this data and more connectivity out there, that data is actually secure. So when we start kind of looking at the threats to that security, there's really kind of comes down to two pieces. We either have intentional threats or we have unintentional threats. So when we kind of look at this with that in mind, when we start talking about these intentional threats, what we're talking about here are really attempts to enter into that network, whether that's just causing havoc, somebody looking for free access to the internet, we're doing MAC spoofing. Basically someone is trying to get out or get into the network from the outside world that we want to prevent. And so Another thing that they're trying to do is to intentionally shut down that wireless network. So these can be denial of service attacks. And then, we also have either stealing that data or these data breaches, or they're trying to inject invalid data into it. Now, this is pretty well impossible if proper security is deployed. That's really the magic part of this is properly deployed security. Usually this is high level type of attacks, kind of at a state level or country to country. So we kind of look at the flip side of this, we've also got to contend with unintentional threats to that security when we start dealing with wireless. So this can be just bad wireless hardware. We may have out of band radio specifications. We may have other users that are off frequency. Okay, what that typically will cause is background noise or interference. So we can have our high RF noise from electrical hardware. These could be your VFDs. It can be static discharging. It can be welders. It can be any number of things that add to that electromagnetic energy that's running in the background. Also, we can have is simply too many users on a single wireless channel. You can actually overload or basically clog up that wireless channel. So what you want to be able to do is to now be able to regulate or control or to basically segment some of those wireless channels so that not everybody is operating on the same channel. Now these can be, your own users. This can also be other users that everything is choosing, say, channel 7. We want to make sure that we do proper channel management. So as we kind of look at these best practices, and again, this is kind of a review of what we talked about a couple weeks ago, is really there's a couple things that we advise. Number one is to, especially within the industrial automation world, is to use static IP addresses. Okay, we want to disable that DHCP services for mobile clients and remote locations. We don't want to give them even easier access onto the network if they bypass or can get past the encryption and things like this. Make this as difficult as possible. Security is really done in layers. So a very good one is to have a static IP that's assigned out only for your devices. The other one is to make sure that you're updating as well as rotating those security keys. We want to use the most up-to-date encryption methods in here. So this, by today's standards, is AES 128 or AES 256. If you're still running some of the old WEP encryption or even no encryption, that's something that needs to be addressed right away. And so you can also go even a step further and go into what we call an enterprise mode, in which you're using an authentication server. Something that's very generically called, or commonly called, I should say, is a radius server, in which you have to basically prove or authenticate with that network as a valid user before that key is passed. You also want to set a good policy to change those keys. Okay, especially if you're using or your hardware is limited to some of the older encryption styles, is we want to make sure that we're rotating that key. And then also that network administrator, so you want to do periodic network surveys. Make sure we don't have any rogue access points on the network, so make it easier for, sometimes users will bring this in so they can bypass some of those the security measures. Make sure you know what's on your network. As we kind of go a little bit step further, is then we also are going to be looking at, the best practice is really use what's available. So we want to enable that client security, update to that latest encryption, disable Wi-Fi access if it's not required. There's no reason why we need to necessarily have Wi-Fi access just because we're using 2.4 gigahertz or 5.8 gigahertz. We can put this into a straight bridging mode in which we control what those users are or reject all of them. We can disable the SSID broadcast so that if people are looking out in the field, they're not going to see your network at least come up on their phone or their computer as the esteemed network. Then you can also, if your devices support it, we can also go into something called protected management frames, which even take this a step further for your unicast and broadcast traffic on the management frames. We can even protect those now. So we kind of start looking at this. Again, that's kind of a review of what we talked a couple of weeks ago. If you weren't part of that, it is up on our website as well as our YouTube channel if you want to go through and kind of sit through that as well. As we kind of dig into this, when we start going through the Esteem Horizon series, because this is really where we're starting to see these network devices out here due to the higher speeds to it, is how do we actually go in and secure that network? How do we configure this with those best practices we typically talk about? So when we start looking at this, basically the first thing that we're going to do is select that mode of operation. Now, this is a drop-down window as we go through the setup chain. Most applications are simply an AP bridge, but we can go into an AP router in which we can now have an isolated or a different subnet for the wireless network, different from that wired network. Or we can even go into what we call a masquerade mode, which is really a firewalled mode. So as we kind of step through, the next thing it's going to ask that you want to go through is, the best thing is just to go through the full setup chain. So on this, you would just want to go ahead and leave that radial up at the top under the DHCP mode and select next. And what that's going to bring you to is the next screen on this, which you can, now all of a sudden we can determine, do we want to be a DHCP client? Do we want to be a server? Or do we want to turn that off so that we basically mandate that everything have a static IP address on this particular Esteem radio? Now we can also be a DHCP server. Then we can also get into setting the root bridge. Now typically this is done where you want that data to flow, say at a master location. And we've talked about that a little bit more in depth in a previous thing, so I'm not going to get into a lot of details about that root bridge and how the spanning tree works, because we're really kind of dealing on the security side. So as we kind of step forward through this, this is where we set basically that static IP address of the Esteem radio. Again, we're going to set the IP address, we're going to set the net mask address, and then you can also define what the default route is. Now this, in a bridge mode, honestly, it doesn't really come much into play, but it can be pointed at your default router. If you're going to try and point this to the internet for things like a firmware update or anything of that nature. Okay, now this is kind of where we start getting into some of those security practices to lock down this network. So first thing really we're going to come to is going to be the channel bandwidth. Okay, by default, this is on a 2.4 gigahertz channel or network, so it's going to come by default at 20 megahertz wide. Now we can also run this at 40 megahertz wide. Okay, one of the things that we can add to our security is, if your network requirements support it, is we can actually now go down to a 5 megahertz wide channel or a 10 megahertz wide channel, in which those are not part of the Wi-Fi standard. So your Wi-Fi devices out in the field, or if it's going to be, some sort of a rogue character, can't connect to that network. That isn't part of a Wi-Fi network. So again, we can check whether we want it to have the highest throughput, or we can also skinny these up if we want to have better security and cut off that need or that access as an access point to it. So we go to the next step. Basically, this is where we can select that channel, and these are done in basically as a drop-down screen that you see there. And these are, again, this is a 2.4 gigahertz system, so there's 11 channels. Now at 2.4 gigahertz, all 11 channels are also Wi-Fi channels. One of the other things to consider, security is really a concern, is if we go into the 5.8 gigahertz frequency band, that supports 17 different channels. Of those 17, only 5 are used for Wi-Fi. That leaves us 12 other channels that are non-Wi-Fi channels, in which we can now run kind of in between those and run on what they call a non-Wi-Fi channel or a proprietary channel, in which now all of a sudden we have a proprietary bridge running out in that 5.8 gigahertz. So we get our nice high throughputs, very secure. We keep anything from getting in on the Wi-Fi side. Again, keep in mind when you're doing this, if you put this onto a non-Wi-Fi channel, or we'd go into a non-Wi-Fi bandwidth, it's also going to prevent your users from getting out there. So again, you want to match to what is going to be your best security practice for this. What is it that you actually want to do? What does your application call for? So we kind of go into this next step. This is where we set the SSID. Okay, so what this is going to do is, this is kind of that name of the network that you would see if you look on your computer for a Wi-Fi network. This is actually what that network is. This is what allows clients to connect to it. Okay, this is where we can also dictate, do we want high throughput rates, which does require WPA2 encryption, or we can use standard rates, which we can now use for kind of the legacy encryptions, would say the WEP or WPA. It also supports WPA2 encryption if you want to go that route. So as we kind of go through the next one, this is where we can actually choose. Now I've chosen the high throughput rates. So what we're going to actually choose now is, what type of encryption. Now this is dealing specifically with the access point to a Wi-Fi client. Okay, so we can use WPA, and there's basically two options there. Is that we can use AES 128 or we can use AES 256. Now, of course, the WPA2 using 256 is going to be the most secure. Now, what you'll also see there is that we have two options for each. We can use the PSK, which stands for pre-shared key. This is kind of that shared password that you're very common with, say, on your home network. Then we can also go into an enterprise mode, which I talked about just a few minutes ago, which is going to be like a radius server in which you can point it at who that authentication server is by IP address on your network. Then what you'll see down below next is where we can actually use protected management frames can be turned on or off. Now, one word of caution is to make sure that your devices that would be connecting to this also have the capability of doing Wi-Fi protected management frames. And so typically kind of a good rule of thumb is that your 802.11n don't support it, but your 802.11.ac devices would support that. But you want to check with your individual devices. Again, this is the Wi-Fi devices that would be connecting into this network is all we're talking about here. Now, another good practice is we can actually hide that SSID from being beaconing out there. So if someone pulls this up on their laptop to be looking for available networks, they wouldn't see this. Okay, so this is something that can be configured by you in the field. A lot of people, what they'll do is they'll get this first up and going, get everything set, and then they can go back in and turn those beacons off. So kind of step forward again. This is where we actually can set that WPA or the WPA2 passphrase. Okay, and this is basically something that you can use to set your own pre-shared key. This is where you would enter what that is. Now, by default, there'll be a value within the Esteem radios. It's highly recommended you change this to a unique password for your establishment or your company or the actual installation. Okay, now as we go through, now there's a couple things on this section, and this is basically what we call basically access control list. And think of this as really a MAC filter. So as you can see there, we have three different options. We can allow all devices, provided that they have the correct SSID, encryption, password, or authentication server, as well as a good static IP address. Now we can allow everybody on there. Now what we can also do that you can see is that we can change this and go to allowing only those station MACs and then you can define by MAC address exactly who you want to allow onto this network. Okay, what you can also do is you see the next radial down there is you can actually even go in and deny those particular MAC addresses. And so if you have, say, a piece of equipment or a computer that was stolen or anything, that there's risk to that, as you can actually deny that particular MAC address. Now, one thing also that we can do here is for kind of another level of security. Say we want to run this out as strictly a 2.4 gigahertz bridge, but we don't want to allow Wi-Fi access. One of the questions that comes in is, well, sure, but what about MAC spoofing? And that is something that we need to contend with. So when we go into a situation like that, really what we do is that we still select allow only those station MACs in the list below, but we leave that list blank. So what this does is any 802.11 or Wi-Fi request that comes into it is denied. So yes, you can spoof MACs, but you really can't spoof a nothing MAC. So this is probably the most secure method to doing this. But again, it depends upon the needs of the application. Okay, so as we kind of go forward, this is kind of where now we're dealing with, this screen is going to be, number one is what creates those bridges like we talked about before. But this is also where we define the encryption between Esteem radios that are now in this mesh or in this bridged network. So what you want to do is select Add, which you see there highlighted. And what we're going to do now is we enter in either the wireless LAN MAC address of the other Esteem, or you can enter in, as I've done here, just the serial number of that other radio, and it will basically pull that MAC address from a field. We've talked about path links, so we're not going to discuss that here. As you can see down a little bit further, where it's highlighted is now we can basically define what type of encryption are we using on this bridge link or that mesh link. This is, again, different from Wi-Fi. This is really just from Esteem to Esteem. So what we can do is really kind of a couple things. Number one is you want to select with the radial of what type of encryption you want to use on this. Now, by default, is we use AES 128 on this link. And that's really to make sure that we go in and we're backwards compatible with some of the older generation radios. If this is a new one, feel free to bump that up to AES 256 for a little bit higher level of encryption. Now, as you choose that, what you'll see is that there's basically a default key that we're using to start that level of encryption. You can see down there, it's highlighted the 11223344 and so forth. That would be something that if you wanted to actually change this key and use your own hexadecimal key, this is where you could actually enter in those values. Now, the other thing, because that starts to get a little bit difficult or confusing, is that now you can also go in just above that, and we can now go in and basically kind of use that and generate a key. So you put in a link ID and then a passphrase to it, and then you select the generate key. And what you'll see now down in the encryption key is it actually generates, based upon those values, a hexadecimal key. Now keep in mind that this method of encryption needs to be the same on everything within that Esteem network, meaning that if you have two devices, both of them need to be using that same key. So make sure that this is something that's noted down, or you can actually copy it, you can copy and paste it, but everything does need to use the same level of encryption on this, as well as the same key. Okay. So as we kind of wrap up on this, that kind of the last few things that we can do on the encryption side of things or on the security side of things is this first field is just a radio ID. And this is really what you want to call the device. So rather than having to remember by IP address or MAC address when you're looking at the status table of this is just a straight text field. So you can call it conference room, you can call it Fifth Street repeater, whatever you want to go through. It's something very simple as really kind of a marker for you. But as you kind of get down below that, what we can also do is there's a discovery suite configuration tool that's used to basically locate these devices. Now, one of the things that allows you to do is to change IP addresses and so forth on this network. So what we can actually do is we can disable the ability of that discovery utility to make any changes on this. Now, you can still discover it, but you can't push any changes to it. Now, if we want to go a step further within the advanced settings, we can actually completely disable this so it doesn't even work within the discovery tool. Be very careful with this if you do that, because if you turn it off, of course, it's not going to work any longer. So again, these are things that depending upon your individual security needs of that application or that network, we can now turn that ability to discover on or off. Okay. What we can also do is disable the ability for us to be able to get in and do remote assistance with you. Now, we don't have access directly to these radios from Esteem, This is something that would have to be done through, a GoToAssist or TeamViewer. Log me on one of these types of services that we could access, but you could actually disable it so that we can't get in there as well. Now, just a word of caution, if you disable this and you forget what your password is on the radio itself, or the person that is the keeper of those passwords is either not present or is fired, there is no backdoor to this. So this is something that would have to be sent back to Esteem to be kind of reflashed or reset to it. Okay, so that's really kind of all that goes into setting this. It's very simple, but it ends up making a very robust and secure network. So we kind of look at the conclusions of this is when we're dealing with security, and we could spend days, weeks, discussing security at different levels of this, but really kind of what you want to do is to realize that wireless security is just the first level in a multi-level security model. So it's kind of that first layer of security. Don't rely on it to be your complete network security, but we want to lock that network down. The other big one is really now is that time to implement or adopt a good security policy. Some of the things that we've discussed need to get put into a policy so that this is not left to chance or to each individual want or need or desire. Okay, we want to make sure that we're going forward with this in the most secure manner. Okay, very high level of security is available, but it's up to you to implement this. We've just gone through the steps that you can see that it takes to make a very secure wireless network, and it is very possible. And so, but it is something that has to be intentionally done. Okay. The other thing that we can kind of consider is, when we want to look at other frequencies, or even like I mentioned within the 5.8 gigahertz, is that we can also have wireless network is available. It's just beyond Wi-Fi. I mean, we can use 900 megahertz with the Horizon 900. We can use one of the non-Wi-Fi channels of the 5.8, or we can simply lock out the Wi-Fi access into any of the radios, even the 2.4. So really it just becomes, what is going to be the best for the application and for your needs. So kind of keep in mind that security isn't a one and done. This is something that is an ongoing process. It does require diligence, and it does require some flexibility, because you do have to go in and make some of these changes. So again, so what we just want to kind of cover today is kind of what goes in, what some of these security measures that we've built into the Horizon are. I was kind of mentioning also of this Horizon 900 that we have, and we've kind of mentioned it a few times in here. But in a couple of weeks, we're actually going to go through and have a webinar specifically regarding the Horizon 900. This is a really unique radio. This was done directly due to you, the customer, in that what people were starting to see is that we need more speed, we need more capability, we need better architectures from 900 megahertz. So we did it. So we actually built you a 900 megahertz radio that can mesh, that gives us up to 72 megabits of RF data rate. That still takes advantages of that 900 megahertz. So we get a little bit better distance, we get a little bit of penetration into some of those nastier environments. So hope you can join us in a couple of weeks. If you got any questions, feel free to either contact us through our website. You can send me an email directly, which is tolly@esteem.com, or you can give us a call here at Esteem. So thank you for that, and basically have a great day.